Dr. Dean.
Mm-hmm.
When will we be able to see our grades for your class?
What do you mean?
Like for everything we've already done. Like, I know we just recently had an exam too.
So all of the grades for your homework and online stuff is always online. Now you can go look at it whenever you want. Just go to.
I mean, for like our class average, like that we do.
I don't calculate. I don't
Okay.
continuously calculate your class average because, for one, there's a bunch of stuff that's not due yet, like all of it. So I would have to like go in every day, re-download everything, edit it all for the spreadsheet, put it all in the spreadsheet, and check it. And it's like for 4 classes, it probably take half an hour to an hour each time. So I don't keep running tallies of your grades because not everything is due yet. And I mean,
okay.
Yeah. So, but you can calculate it with the breakdown that you have in the syllabus. Just take your homework average, put it in there. Take your average for the tests, put them in there. I mean, not a whole lot to it.
Okay.
I mean, you can check your midterms, and assuming that you like do the rest of the work, because of the situation, things are going to get graded with, we'll say, care toward the end. So, you know, I mean, assuming that you have been doing stuff, and you had an okay midterm, it probably hasn't changed much or hasn't changed for the worse any. All right. All right, give everybody else another minute or two to get in, and then we will start things off. And please remember to sign in.
What's up, Dr. Dean?
How we doing?
Not too good. Power went out, cuz.
Yeah, we got hit hard last night. We had, trash cans all over the yard. And I think power flickered a couple times. Kids were losing their minds. It was a good night. I feel you, man. Well, appreciate you coming in today.
Yes, sir.
Okay. So showing you guys the lead set of notes that we're going to start off with. Just to give you an idea where we will be. So we've been talking about data sets. I'm going to try not to jump too hard in today, just because I know it's Monday and all that. We've been talking about data sets. We've been talking about, so far the sets have been pretty small, but we've been trying to see, can we extract certain numbers or qualities of that data that tell us a bit more about what is going on, so that we don't have to look at every single number or think about every single number. We can kind of reduce all the useful information in that data set down to something that is more manageable, easier to talk about. We talked about standard, mean, median, and mode, which are kind of the averages. And we started talking about location of specific data points when we talked about quartiles and percentiles. So one thing that usually gets talked about with mean, median, and mode, what's the fourth one? Does anybody ever do this in, I don't know, middle school or high school? And there's always a fourth one that gets mentioned with those other three.
Range?
The range, yeah. And nobody likes it because the other ones start with M and, it has an R and it's, kind of the outcast of the family. But the range is a very important part. And it's what we are going to be talking about today. But as we already saw in section 10.2, sometimes data is too spread out and is hard to distinguish from close together data if you're only using a mean, you're only using an average. So one of the ways to consider the spread of the data involves looking at the range. And another way is to look at the data is to construct a box plot from the quartiles. Another measure not covered in this course is standard deviation. Once you start getting into the standard deviation, it's very simple to kind of explain what it means. And it's very helpful if you're going to go into business or anything like that. But the math behind it is well beyond the scope of this course, we'll say. So we're just going to kind of leave it to the side. So let's start off with some of our definitions. The range of a set of numbers is just the difference between the biggest number and the lowest number. So nothing too involved there, very simple. And number two, a box plot, sometimes called a box and whiskers plot, is a drawing of the data consisting of the minimum value, the first quartile, the median, the third quartile, and the maximum value. So these are the things we're going to get into today. Here's my book went away. Well, I'll start us off with a problem. So find the range for this list of 11 different movie times in minutes. I'll let you all check that out while I pull up my notes. So what is the range of that set of movie times?
When we find the range again, what you got to do again?
So it's the difference between the biggest number and the smallest number.
It'll be 113 minus 80.
No. 155.
Oh, yeah.
Yeah.
Minus 88.
Yeah. So you got the low one, and then the high one is 155. So the range of this data set is
67.
I think I agree. So 155 minus 88. Yeah, 155 minus 88 is 67 minutes. Yeah. So this is the same data set that we use, that we've been using previously. It's a great way to go about it because you get kind of comfortable with the numbers, and so the meaning behind them kind of pops out a little bit more. But yeah, so range is just the highest movie time minus the lowest movie time. Let's do that other one. What about the range for the list of 12, the 12 student scores?
98
Okay.
minus 67.
98 minus 67, which is what? Well, it's 8 minus 7. So 98 minus 67 is 31 points. Very good. So this is the range of our data, which by itself is, not terribly bad. It gives you kind of an idea. But one thing you really need, range is usually a supporting actor, okay? It's usually a good way to tell how the data set looks compared to if you've already found the average, the mean, the median. I'll ask that question in a second. So you are going to use the range often compared to the average, the median, the mean. And that is what will tell you what your data kind of looks like, the spread and that kind of stuff. So, and you'll see what I mean in a second. We're going to talk about the box and whiskers plot thing. So let's see. So a box plot, sometimes called a box and whiskers plot, is a drawing of the data that consists of the minimum, first quartile, the median, which again is the second quartile, and then the third quartile, and the maximum value. So this kind of just shows us what our data set looks like in a nice, cute little graph, which we'll do here in a second. We're going to do it for this data set. Okay. So first off, what is the range of that data set?
It's 7, huh?
Well, what's the highest value?
15.
15. What's the lowest value?
8. Oh, my fault. 2.
Yeah. So what's the range?
13.
Yeah. Yeah. So often numbers might be in order just because it's easy to find this stuff when they are in order, but they won't always be. So I know it's Monday though, so you get a pass. All right. 2, 4, 13, 14. All right. So yeah, so the range for that first one is 15 minus 2 equals 13. So we're going to do this box plot thing. So here I've tried to make a little number line, and we've got, I'm going to put numbers on it, obviously. I'm just going to do every other one, otherwise it'll get really cramped. Okay. So we need to find all of these values. Minimum, Q1, Q2, Q3, and the maximum. So what is the, for this data set, what is the, we already have 2 of these up on the board. What are they?
The minimum and maximum.
Yep. So we've got minimum is 2, max is 15. Then we have, let's see, share back. And we, just for these purposes, we went ahead and gave Q1 Q2 and Q3, 5, 8, and 10. So the way this works is you draw a box. So Q1, 5, 8, and 10. So we've got all of our numbers up here. First thing you do is you put a line. I guess there's no determining way to have to do this. This is just the way I suggest. Is you put a line, or we'll stay with a line, above every point. So minimum is 2, Q1 is 5, Q2 is 8, Q3 is 10, and the max is 15. So we have just a line over each of these. So this is where the box and whiskers comes in. First thing you do is you draw a box with the middle 3. All right. So nice, simple little box. Nothing too wild going on there. And then the whiskers come in where you take that plot and you connect it, or that box, and you connect it to the minimum and maximum values. Make that a little thicker. So we have a box and whiskers. The idea is that if Q1 means that 25%, there's 25% of stuff less than that, and Q3 means there's 25% of all the stuff more than that, pretty much. That means half of the stuff is inside this box. And the other remaining half of stuff is split. A fourth of it is over here, and a fourth of it is over here. So this tells you visually, very nicely, a lot about what's going on in this set of data. So if the box is very small compared to the whiskers, then you have a generally concise data set. Most of it is very squished together, but then you have a couple outliers on the outsides that can mess things up. Like that in that previous data set, we had, let's see, where's my cursor? In the previous data set, this one, most of them are pretty much together, and then this guy just comes in and ruins everything. So this one would have a very small box and then a huge whisker on the high side, big old whisker. But this is the idea. This is a nice visual way to see what does all of the information look like. So let's look at the next one. All right. Okay, so draw a box plot for the data set here. I'm going to do this box plot probably on top of the other one. or kind of with the other one. So 17. So what is the minimum and maximum in this data set? What are the min and maxes of this data set? It's the biggest number. Am I sharing the right one? No, that's right. So the biggest number I see is 19. The lowest number, 10. So back to the drawing board here. Go ahead and do our lines. So we've got a line on 10, 13, 15.5, so in the middle there, 17, and 19. So we have our box and our whiskers. So very similar looking. The boxes are about the same size, and they are flipped around. So this one has the long side right here. This one, I think this side is a little bit longer. But the boxes are about the same. The ranges are very different though. What is the range of the red one? What? So the range is 19 minus 10.
No.
So this one has a range that's almost 50% bigger than this. So it's like 44 or 5% bigger or something. But it is a good bit bigger. And since their middle boxes are about the same size, that means that most of the data in this red one is actually a lot more tightly packed than the data in the other one. And this is what we're talking about when we talk about the spread of data, is just the range itself isn't very helpful necessarily. So if I said that there was a data set had a range of 9, well, you could have a very compact data set with a bunch of numbers that are between 1,000 and 1,009, or you could have a bunch of numbers that are like between 0 and 9. That's pretty spread out because the range tells you how spread out it is when it's measured compared to the median. So where's my, don't have one, okay. So we compare the range to the median or mean to get the information out of it that we want. So if we do that, usually the best way to do it is in a ratio. So you take the range and divide it by the mean and see what you get. So let's do that for these up here. Actually, I'm going to say average because, again, average could be median or mean. Usually it means the mean, but so for the first one, we have a range of 13 and a median of 8. And if I do this in decimal, get about 1.6. If I do it over here, range of 9 and a median of 15.5. And this is about 0.6. So when we were just looking at the range, we said that the range for the blue one was about 50% bigger, which is not bad. Or I guess it doesn't really mean anything yet, because we're trying to figure out how spread out is this data. Is it all over the place? Is it, pretty concise? That's what this idea is. So what we do is we need to see how big is that spread compared to how big the numbers are, because usually bigger numbers will have a bigger spread. And smaller numbers have a smaller spread or range. So if we divide the range by the median, how big the middle number is, we get an idea of just how spread out that data is. Well, when we do that, we see that the spread is not 44% or whatever, which would be that difference of 4. We see that the spread in percentage is not do it in green. So it's actually about 170%. So when you do this, you get a very good indicator of how spread out your data is. And like we said, we won't be covering it, but this is the idea behind, we'll say kind of behind standard deviations, okay? So there's a lot more to it than just taking a number and dividing it by the mean. But basically, they look at how far away is the max from the middle, how far away is the bottom, the minimum from the middle. They also tell you how far is the third quartile from the middle, and the first quartile from the middle. So this standard deviation tells you all of this information together. We won't get into that, but it's based on this same idea, is that the spread itself, the actual range, doesn't really tell you a whole lot. It tells you how big, the numbers that you're seeing could be. But until you compare it to the median or the mean, it doesn't really have much context. So that's why we treat range differently, because it's kind of a supporting role. And then, yeah, so this is all about the dispersion or the spreadedness of information. Cool. All right, well, any questions, comments? Otherwise, that's all I've got for today. Nope. All right.
What time office hours is again?
I'm sorry?
Office hours again?
So I am in Discord from, really, I'm in it all day. You probably heard it beeping in the background. Some people were talking to me. But I am available to jump in for direct help, or you can log on and voice chat with me, or we can set up a Zoom meeting between 12 and 1, and then 2 to like 3:30 usually on Monday, Wednesday, Friday.
I'm looking at them hands. You got them on yesterday. All right, I got you.
Cool.
All right, thanks, bye.
All right, y'all have a fabulous rest of your day.